I'm Anil Kumar, and now let us review some characteristics of polynomials. The question here is, how many possible x-intercepts can a cubic function have? Provide examples with equations. So let me sketch few cubic functions, and then we'll be very clear as to how many x-intercepts can a cubic equation have, right? So I'll draw three different figures. Let's consider x cube, right? So x cube, the graph of x cube is kind of like this, right? So that is x cube. Now clearly it has one x-intercept. So let me write y equals to x cube as an example. Now you know cubic functions and behavior is that they'll go from one infinity to other. If the leading coefficient is positive, right side is up, they will go from quadrant 3 to quadrant 1. However, if the leading coefficient is negative, then they will move from quadrant 2 to quadrant 4, right? So let me give you another example. Let's say a function moves from here. It's a cubic function. It has to turn back to get into quadrant 4, and that results into two x-intercepts. Do you see that? Now let us say this x-intercept is at -1 and this one is at, let us say, +1. In that case, what we notice is that the graph equation could be -1. It is two zeros here, so we'll say x plus 1 whole square, right? And this one is at +1, linear 0. Its factor will be x minus 1. Since the right side is down, the leading coefficient should be negative. Is that okay? So we'll keep this negative because of the end behavior. Now you can be specific in this example. If you want, you can give the y-intercept. Also, if x is 0, then the value of y will be 1 times -1 times negative. So this value is also +1. So that becomes the graph of a cubic function which has two x-intercepts. Do you see that? Now, can you give me graph of a cubic function which can have 3? Well, now let's take one with positive leading coefficient. That means right side up. We want 3. So let us say we have a function which is kind of going like this. So this also is a cubic function, and here we have 3 x-intercepts. Let us say this one is at -2. Here we have 1 at 0. The next one is at +1. The equation for this can be y equals to, since this is minus, we could write this as x plus 2. Now here this is at 0, so it is just x, and because of that we have a factor x minus 1. So this is also a cubic function which can have 3 x-intercepts. So what we conclude here is that a degree 3 polynomial, odd degree 3, so it is odd degree, right? In this case it was degree 3 polynomial has 1, 2 or 3 x-intercepts. Correct? Now what you need to check is that odd degree, let's say the degree is n, then how many x-intercepts can this polynomial have? Now since odd degree has to go from one end to the other, it will always cross the x-axis. So at least 1, right? It could have more, up to n, right? Up to n. So the number of x-intercepts which odd degree polynomial can have is from 1 to n. So these are all the possible solutions. So you can make now graph showing x-intercepts when n is equals to 5. So you can draw 5 different scenarios where the x-intercepts are from 1 to 5, right? I hope that helps you to understand that odd degree functions will have x-intercepts from 1 to n, where n is their degree. Thank you.